And welcome to CSIT 165 Module 9 Data and Visualizations. For data and visualizations, we're going to be exploring what data is, how it's going to be presented to us, what we need to know to make of it in order to do an analysis, and then we're also going to be going over some of the basics of visualizations. For this week's in Module 9, we're going to have to do some reading. For the first reading, we're going to have to read chapters 9 and chapters 15 in Programming Skills for Data Science. We're also going to have to read chapter 6 for R for Everyone. This week we will also have a graded discussion 9, as well as a midterm vignette. The midterm vignette isn't an assignment, but is merely an HTML page vignette showcasing some of the things that we've learned in the class. It can be used as a quote-unquote cheat sheet or something as a quick reference to kind of sum up how to do certain things with vectors, lists, functions, if-else statements, for loops, and data frames themselves. We also have links for the group project. As a reminder, the group project 1 is due on April 5th at 11:59 p.m. That's Sunday at 11:59 p.m. The team synopsis is also due on April 5th 11:59 p.m. The team synopsis is a mock scenario where you're given $5,000 to allocate to different members of the team depending on their contribution to the project. As a look at the vignette, you can see that we have different things like documentation, going over a YAML, so going over different formatting things with making our markdown with title, author, date, output, PDF document, or HTML document, using a table of contents equals true, which is how I created this, and then using a table of contents depth equal to 3. What this means is that we're using headers with up to 3 hashtags, but any headers with up to 4 hashtags are not included in the table of contents. For more examples of YAMLs, you can look at R Markdown, the definitive guide, or you can look at Bookdown, authoring books and technical documents with R Markdown. The vignette or cheat sheet also goes over some of the code chunks, some of the different things that you need to do in order to make code chunks. It goes over vectors, how to print vectors, how to create vectors, how to determine lengths of vectors, and how to subset vectors using bracket notations. We also go over how to do very similar principles with lists. We go over how to do lists, or what are the differences between lists and vectors, and how to call on lists, and the different ways that we can subset them. We also go into different aspects of controlling flow using if and else statements. We go into a little bit of detail about functions, but a lot of the details that we go into are how to manipulate data frames. The data frames and the ways that we manipulate data frames in this are somewhat medium to somewhat advanced, and understanding how to use how to do the manipulations in the data frames in this vignette will also allow you to manipulate the data frames in a necessary way to fulfill the project or the group project that's due on Sunday at 11:59 p.m. So this week we're going over Introduction to Data and Visualizations. What are Introduction to Data and Visualizations? Well, in order to analyze and visualize data, we need to be able to access and interpret data sets. By transforming data into actionable information, we can begin to ask meaningful questions about it. Transforming data into actionable information, however, requires that we develop a clear mental model of what the data represents. Understanding data for analysis is predicated on knowing how the data was generated, how to access it, what type of data it is, and how the data is stored. Only after understanding what the data is can we then seek to make meaningful interpretations from the data. Interpreting data requires that one has domain knowledge on the subject and understands the data schema. Data visualizations allow you to reveal patterns in your data and communicate insights to your audience. Learning how to visualize data in a meaningful way requires that we understand the purpose of visualization, select a visual layout based on our data, and choose optimal graphical encoding to represent our data, as well as understand how to construct our visualizations from an aesthetic point of view. These concepts are fundamental as good programming is only as useful as their interpretations and representation of the data. This module will heavily explore the data and how we can visualize it with readings and discussions. As an example of what some of these different data schemes are in R Markdown, we can come to R Markdown here. Here we have a few data sets. We have Star Wars, and we have something called PikyDT. PikyDT is a data set that I've created myself in the laboratory that I work in, where I use bioinformatics to report how many genes or read lengths for different genes of all the different genes in a specific type of yeast. As an example of this module, we'll be using these two data sets to go through it. As far as data is concerned, this module will go over how data is generated. Data can be generated using sensors, surveys, record keeping, or in the case of PikyDT, ribosome profiling using high throughput sequencing to analyze what genes are being translated at any moment in time. This module will also be going over how we'll find data. We can find data using research articles like Nature or using social networks. We can also use online communities like Kaggle. The structures that this data is most often found are in a table format. Star Wars here is in a table format, whereas we have rows 1, 2, 3, 4, and then we also have columns: name, height, mass, hair color, skin color, eye color, birth year. In this table, we can see that each row represents an element or an item, and each column represents an observation on that item. So we have features and we have observations. The features would be the features pertaining to that cell or that observation, and then we also have observations, which are the values for those features pertaining to that specific row. So what are some of the things that we need in order to do to be able to actually interpret some of our data? One of the things that we need is domain knowledge. Domain knowledge is having context for the data. That's having a basic understanding of what the data is and how the data was made. Having this understanding of the data about what it is absolutely necessary to create meaningful interpretations from the data. In our examples here with Star Wars, it's not so difficult to understand what some of the domain knowledge is. We're talking about Star Wars here. We have characters. We're going over some of the different attributes related to those characters of Star Wars. And some of these attributes related to these characters of Star Wars are very familiar to us because they're attributes that we can use to describe ourselves. We have a home world for ourselves. We would say maybe Earth, and species would be humans or Homo sapiens. And we can see that it has a lot of columns that might be familiar to us. And these columns are especially familiar to us if we've seen the movie series Star Wars at all. Some of these names would also be familiar to us, like Luke Skywalker, R2-D2, or Darth Vader, as well as some of these other ones like Obi-Wan Kenobi, or Chewbacca, or Han Solo. A lot of these characters' names are input into this table. Another thing that we need to understand is data schema, and that's what is represented by the rows and columns. Some of the things to understand domain knowledge, to have domain knowledge for, and to understand the domain schema, or some of the things to look out for, are metadata, which is data about the data. So that could be how the data was collected, what some of the units inside of the data are. And so inside of Star Wars, it doesn't say what the units and height are. We can assume this could be inches, it could be meters, it could be feet, it could be centimeters. And so what we have to do is we have to kind of take a reasonable approach to interpreting what this means. The same thing is said for mass. We don't understand what these units of mass are. And these are things that are important for looking for inside the data schema. Now, data schema and understanding the domain knowledge is especially important as we get to topics or we're doing data analysis where we might not be as familiar with the subject. A lot of people are familiar with the subject, but a lot of people might not be familiar with genetic features related to genes involved in yeast. So we can see here inside of this table that we have 5,329 rows, which is a lot larger than the 87 rows for Star Wars characters. There's a lot more characters, um, genetic characters in the cell than there are characters in Star Wars. As well as the fact that we have 59 columns. So we have different features related to each of those 5,329 genes, whereas over here we only have 13 features. We can see here that as we go into some of these features, some of their meanings might become more esoteric. We can see for ID that it seems to be some number with some name attached to it. The gene seems to be some weird combination of characters and numbers that might not seem familiar to most people. The description seems straightforward. We can see here and probably interpret that the gene's descriptions are located inside of the description field. But then we also have these other gene or descriptions with these other weird names that might not seem familiar. This is where metadata would be very important. Metadata explaining what some of these features would be helpful to someone that doesn't understand how the data was collected in the laboratory or might not be familiar with some of the nuances associated with this type of data. So these are things where data schema and other things like that will come into contact. As far as this is concerned, we also want to look out for what some of the acronyms mean. A lot of these acronyms like TSCP and then having a Boolean statement false or true, or TCDMD having a number 0, 12, 2, that might not be familiar with a lot of people, and so they might not understand that it's referring to how many transmembrane domains that protein has, or so on and so forth. So understanding the data is very important to being able to make any sense out of it and making any valid interpretations from it. Going back to a more simpler example with Star Wars. We can see that having that interpretation of the data, understanding how to manipulate the data, are very important for making interpretations or for making conclusions about that data. Some of the different ways that we can make conclusions, though, are through visualization. Visualization is a means to an end, meaning don't get too fancy with your visualizations of your data. The point of the visualization isn't to woo or impress or to be eye candy for the reader, but is instead most important to prove a point, to show some sort of underlying pattern, or to expose some sort of fundamental correlation between data that might not otherwise be observable just from looking at a data table itself. Sometimes the visual cue and hint of actually being able to see data come to life can really impart a lot of meaning, such as, a photograph is worth 1,000 words. Well, so is a visualization. So when we're trying to make visualizations, this module is going to be going over a lot of things that we need to do to consider. Some of those considerations that we need to do are to choose layouts. And choosing the layout of how we actually visualize data will depend on the question that we want to answer, what type of data that do we have, and maybe some of the limitations of human processing systems / media. With the limitations in human processing systems / media, we don't want to bombard our reader with a billion data points, maybe, that have text labels describing what each of those data points mean. No human viewer can look at a figure and see a million data points and see all these different text labels to those data points and actually be able to make any sense of it. So having an understanding of maybe what the human brain can actually process at any one point in time, so that it's still simple but meaningful, is both an art and a science. So we'll be going over how to do that and maybe some examples. As far as choosing a layout, one of the things that we have to first look at is well, how many variables are we looking at? Are we looking at one variable? Are we looking at multiple variables? If we're looking at one variable, such as height or hair color or eye color, we can do certain things to visualize it, such as look at the distributions of those variables. With mass, we can count the amount of times that the mass 77 pops up or 136 pops up, and then we can plot those values. Or we can plot the amount of times that hair color pops up or the distribution of that. And so some of the ways that we would look at distributions, and although we haven't gone through ggplot, as I go through some examples of some visualizations, we will be going over ggplot next week. The primary thing to take from this demonstration is how we're using certain plots, why we're using those plots, and what type of data we're using in order to plot those, as well as what type of questions some of these plots might be able to answer. So as far as single variable plots, we can look at the distribution using histograms. And so for this one, we can see that this is a histogram of the age distributions of Star Wars characters. So here we have Star Wars characters that are 0 years old or very young, and Star Wars characters that are up to 800 years old, as well as the amount of times that characters that are in those age groups are actually pop up inside of the data set. So we can see that most of the characters are around, I don't know, maybe around like 60 or 40 years old here or so. There's a lot of characters that are between 0 and 100. Most of the characters are between 0 and 100. I think that's fair to say from this data. There are some very old ones that might be something like Yoda out here in the outskirts. We can also use box plots for distributions. An example of a box plot, or when a box plot might be necessary, is if we're using a box plot of the distributions of different heights for different gendered Star Wars characters. So perhaps we want to see if if there's some sort of correlation between height and the different genders for Star Wars characters. We understand that usually on Earth, humans have a distribution where males tend to be taller, but this might not hold as true or on different planets or when you take into account different species. And so maybe Star Wars data set's good for looking at that. And so here we can see a box plot, whereas all these dots represent data values that are outside of the standard deviation away from the mean. The mean would be this bar here. So you can see that the mean for the female height is around like 160, and the mean male height looks like maybe around like 170. And then you can see that it maybe has a larger standard distribution. These are areas where distribution for single variable plots might be appropriate. As far as what else we can do is we can also do violin plots. Violin plots are another way of looking at distributions, but instead of having a range going in a y-axis here, we have a range that goes in an x-axis, whereas the thicker color points represent more data points that are between those values. So we can see here that there are more characters in Star Wars that are with the height between 150 and maybe 170 than there are characters with the height between 100 and 110. And we can see that because the area of the violin plot is greater in those areas where we have higher distribution of values from a data set. We can also use multiple variables to make visualizations. Some of these multiple variables might be a pie chart, for instance, where we can count the distributions of different genders inside of Star Wars. So here we can see that most of the characters inside of Star Wars are male. Here you can see that there are some that have none, and that could be appropriate for some of the droids or whatever. And then there are some that share both female and male characteristics. And you can also see that there's a small but a somewhat sizable portion of female people in Star Wars. But from these types of graphs, this would be a good graph to showcase how many more males are in Star Wars than females. Um, this kind of graph would be to showcase the average heights of different genders in Star Wars. And this would be the same thing, except maybe to show a little more information about with statistically with the median or mean, and that might be appropriate if your question is asking that. And this one is just good for showing the distribution in age. So we can also do other different types of continuous variables. Uh, Such as a pie chart with eye colors. So in this example where we use genders, there's very few options that we can use for gender. In this case, there's 5 options: female, hermaphrodite, male, none, and none at all, or NA. We can also use uh, groups with a lot more variety, such as eye color. So you can see here that we have black, blue, blue-gray, all the way up to yellow. We have several varieties. And then you can see how it actually starts to kind of blend inside of the pie chart. This would be less useful as visual analysis, but it could be useful if some of these colors are grouped into bigger subgroups. Um, and maybe you could have those subgroups here, and you could show the distribution maybe, and that might be more meaningful. Um, but as I said earlier, the reason why I'm going through these examples is to think about the different considerations of when you would use certain plots and when you wouldn't. Maybe what some of the advantages or disadvantages are, and so on and so forth. The final example, and probably one of the most common examples for um, using multiple variables, is when we have continuous variables. So this is good if we have categorical variables. Category meaning an eye color. It is this or it is not this. Sometimes though we have continuous variables, which would be a number. And so in instance of that, if we're looking at height and mass, so we can make a scatter plot of height versus mass here. And you can see here that on the x-axis we have height. So as we grow taller, and then on the y-axis we have mass. So as we weigh more, and so anything that's over on the right side of the graph are things that are very tall, and if it's on the right side of the graph and very high, then it's very tall and very heavy. If it's right side of the graph very low, then it's very tall and not very heavy. And likewise, if it's on the left side of the graph, then it's very short, and if it's very low on the graph, then it doesn't have a high mass. And so we can see here that there is maybe some general trend, and maybe we would use a scatter plot to show that there's a trend in characters being taller and also weighing more. Perhaps when we look at this, though, we can see that this dot kind of skews our interpretation of these other dots here. We can see that this dot looks like an outlier and kind of prevents us from being able to see the general trend that's going on with some of these other dots here. And I'm using terms like general trend so that I don't have to go into, or the class doesn't need to go over statistical analysis and actually view regression and different ways of actually making meaning from this. We just want to be able to get our data into a format and make basic visualizations for showing things. So let's say that we wanted to make this a little more, this correlation a little more observable. And so the first step that we want to do is we want to say, hey, what is this dot up here? Well, we can use something called pre-attentive attributes to highlight or to make a graph or a plot that will highlight that dot, as well as we can use labels to find out, to automate what that dot is or what data point this dot correlates to, and then give the label for it. So we can see here that the outlier in this group is Jabba the Hutt. I don't know how to say his middle name, but Jabba Desolatier. Yes, so he's very heavy. He prevents us from being able to see this. So what we can do to see this trend a little better is maybe we can subset the data so that we do not include Jabba the Hutt. And if we do that, then we can see a really nice or a much more evident trend of the height versus the mass. Whereas the heavier or the taller we grow or the taller the characters are, the more they tend to weigh. And that's something that we would expect to see. And so this is an example of some of the limitations of using certain plots, and maybe some examples of how you can use pre-attentive processing, maybe some certain scenarios of why we would want to subset our data when we plot it so that we can show trends better. But all in all, the point is that we're using these visualizations to make statements about our data so that we can convince our reader of something. In this case, we are convincing our reader that taller characters also weigh more. So this concludes the very basic umbrella periscopic view of data and visualizations. If you have any more questions, please feel free to email me or set up an appointment via Zoom. Thank you.